Okay, now let's see some exercises about arithmetic progression. In here I want you to tell me if there are actually any kind of arithmetic progression, maybe increasing, maybe decreasing, or even constant arithmetic progression, or maybe they are not an arithmetic progression at all. They might be some progression, but I'm only interested now if they are arithmetic progression. Now, please pause the video for a minute, think about it, and then we just come back. Okay, assuming that you have paused it for a minute, the first thing I want to do is let's just find out what the common difference is. Okay, we're going to calculate D first. So what is D in here? Let's think through. What would be D? Remember what we do for a D? We just make this one minus the previous one. So D is going to be minus 2 pi minus pi. This is minus 2 pi plus pi, and this is going to be minus pi. Well, we have a negative D, okay? We have a negative common difference, and this means that and please check, okay? Minus pi works, minus pi works again. Test for everybody, okay? Don't just do the first 2 or 3 terms, because it might be a tricky question and you might get the wrong answer. So this is going to be a decreasing, okay? Decreasing arithmetic progression. Okay, again, pause a little bit and then come back. Okay, assuming that you just pause it, let's first try to get our D. Well, from here to here, what do you get? We get a plus 4, right? Again, plus 4 works, and again a plus 4. So it is indeed, let's take any arbitrary terms, like 25 minus 21. This is a plus 4. We have a positive common difference, and that means that we are going to be dealing with an increasing arithmetic progression. And then just go over and over, okay? I would advise you just to pause the video and think through. Well, I'm going to do this straight on, okay? This one minus this one, 0. Okay? This is going to be 0. This is a constant, right? So we can say that this is a constant arithmetic progression. This one, 1, 2, 8, 4, 8. Well, plus 1, plus 2, plus 4. It's weird, right? Okay, it's not constant. Actually, it's not the aim of this exercise, but I'm just going to say D is different than a constant. This is enough to say that this is not an arithmetic progression. Well, further we are going to see that this one, it is a geometric one, right? Because times 2 times 2 times 2. When the factor it is times something, this is a geometric one. But for now, it's not an arithmetic progression. It's more than enough to state this. Let's go for this one. 12, 15 plus 3, right? 15 to 18 plus 3 again, okay? And then you might say, okay, this is enough to say that D, it is a plus 3, then it is an increasing arithmetic progression. And just go D equals 3, and then arithmetic progression increasing type. Well, that's wrong. And so why is it wrong? because what I told you in the beginning, test for everybody. Plus 3, plus 3, plus 4, plus 4. D is not constant. This is not an arithmetic progression as well. We gotta have the same constant over and over for each next term. Now, let's see this one. This one is interesting. Well, we now have the general term. Well, if you're not used to it, you're going to see at the bottom here. That's why the exercise are good for. But if you don't know just by looking, in the end you must know, but just by looking at the general term. But if you don't know yet, well, the best way I can teach you is this. Construct, build your sequence, visualize your sequence. If you have the formula to build it, just do it. N equals 1, 1 minus 1, 0. N equals 2, 2 squared, 4, minus 1, 3. N equals 3, 9 minus 1, 8. N equals 4, 16 minus 1, 15. N equals 5, 15 minus 1, 5. 25 minus 1, 24. N equals 6, 36 minus 1, 35. Well, I think this is enough. Let's see what is going on. Plus 3, plus 5, this is enough. Okay, when you just acknowledge that this is a plus 3 and this is a plus 5, this is enough. I don't have to see the rest. This is enough to say that this is not an AP. Why? Because D, it is not a constant. It is changing, okay? And therefore not an arithmetic progression. And let's just build the chart of this thing in here. It's interesting. Let's build it. It's interesting to see that. Let's build the charts. I love to build the charts. It's amazing how much we can get from it. Well, it starts with 0, then 3, then 8, then 24. So it's going to be something like this. Something like this. Okay? This is never possible to be. This is going to be a half side of a parabola. Okay? And this is never going to be an arithmetic progression. Why? Remember when we said initially that the arithmetic progression, let's take a minute to recap something. When you are dealing about arithmetic progression, it doesn't matter where that line is going to pass. Okay, but it gotta be a straight line. Okay, this is an arithmetic progression. It gotta be a straight line. And remember the equation for that line: y equals ax plus b. This is meaning the x must be first degree order. In here it is second degree. Now you don't have to build any more of this. Whenever you see that the term in here, the x, the n, doesn't matter, it is square, it is not the first order degree, it's never going to be an arithmetic progression. This, to be a line, a straight line, it must be first degree order. So whenever you see squared, thirds, n n to the power of half, if it's not 1, it's not going to be arithmetic progression. Okay, okay, and yes, and that gave me another interesting idea I'm going to build here something like this, to the power of c. Now it's much better. It's much more complete. This one is getting better and better. This is the most important exercise. Okay, so hold on until we get there. Now, next one. Let's see this one. Well, power 1, right? Seems to be good. But maybe you are not so sure. Okay, because of this -1, you said, oh, I don't know, I'm suspicious. But I remember Marcelo told me that if this is first degree order, this 2 in here, this 1 in this case, then we get ourselves an arithmetic progression. But let's see. I'm suspicious. I'm not sure. I think it is, but let's just be sure. Now n equals 1, 2 minus 1, 1. N equals 2, 4 minus 1, 3. N equals 3, 6 minus 1, 5. N equals 4, 8 minus 1, 7. N equals 5, 10 minus 1, 9. I think it's enough to see that we have our common difference being just a +2, right? I don't think we need any more term to define this. And therefore, this is, because it's a plus, this is an increasing arithmetic progression. And if you just make a chart out of it, it is going to be something like this, or something like I don't like. Let's make math. It's not something like, I think, maybe. Math, it is or it is not. Okay. Now, well, I know this is a line. This is the equation of a line. Okay, so I'm going, but before that, okay, and I know that the tangent is going to be 2 and it's going to pass through -1. So I know that this line is going to pass through the negative part. It's going to be like something like this. +1 is 45 degrees. It's going to be something like this. Okay, because the tangent is 2. Remember, the tangent of 1, it is 45 degrees. So the tangent of 2, it must be higher than 45 degrees. That's why I made something like 60 degrees. I don't know, but it's higher than 45 degrees for sure. Well, let's put it. The first term is 1. Maybe let's put it this way. Yeah. So the first term is in here, 1. The second one is going to be 3. I'm not going to be able to put too much. And the next one is going to be 5. It's going to be in here. I'm not going to put it, okay? So this is going to be 1. This is going to be 3. The 5 would be here, okay? And so on. But this is a straight line, okay? And when we take the equation of this is y equals, the tangent I know is going to be 2x minus 1. When x is 0, this is x, this is y. When x is 0, y it is -1, okay? This is -1 when x is 0. That's why I knew that it would cross in here. So whenever we have a line and our sequence it is along this line, we can be sure we're going to have arithmetic progression, okay? Because this is 1. This is the most important part, okay? If this is +1, -2, it doesn't matter, okay? Because this is only going to change n equals 0, but for sequences n must be equal or greater than 1, so it doesn't matter this for us, at least not for deciding if it is an arithmetic progression or not. Now let's go to this next one, -3. Well, it is going to be, okay, we know that because this is first degree order, this is 1, okay, n to the power 1. Okay, but if you don't know it, let's do it. What is going to be? N equals 1 minus 3 with plus 1, it is minus 2. N equals 2 minus 6 plus 1 minus 5. N equals 3 minus 9 plus 1 minus 8. N equals 4 minus 12 plus 1 minus 11, and so on. Well, we can see that we are just adding how much? Negative 3, right? Why? Because we are going into deeper and deeper into the negative sides at a pace at modulus 3. So D, it is going to be minus 3. Well, if you have to do it, you do what? D equals minus 8 minus minus 5. Minus 8 minus minus 5 is minus 8 plus 5. Minus 8 plus 5, it is minus 3. Well, now we know that this is going to be a decreasing arithmetic progression. And let's see what is going to happen if we just chart it. I'm going to make the chart because let's see. Let's take this. Let's take this one. This chart here for this one. It's going to be too messy. Okay, now I think it's better. And this one is for this one. Okay. Now let's do very quickly. Oh, don't have to be too quickly. Okay. This is going to be X, this is going to be Y. Okay, if we know how to draw those lines, you're going to see that because the X, the A, right, this coefficient in here, it is negative. This is tangent. Where do we have the tangent being negative? Well, the tangent like this is also positive. The negative tangent, it is this. Okay, whenever it is greater than 90 degrees, the angle greater than 90 degrees, because up to 9 degrees it is positive. When it reaches 90, we don't have the tangent of 90, and greater than 90, okay, we start to have negative tangents. Okay, negative, 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 and it goes until we reach 180 degrees. Okay, so this is going to be a negative tangent, and it's going to pass through points plus 1. It is going to be something like this. Okay, and this is going to be plus 1. This point in here is going to be plus 1. Okay. Well, I'm not going to care too much about stating, okay, the numbers. Let's suppose this is minus 2. This is the first term. Then it's going to be negative 5, okay, and then negative 8, and so on. So this would be our negative 2, the first term. This should be the first term, again, the first. This should be our second term, and this should be also our second term, and this is minus 5, and so on. Okay, and the equation in here, it would be something like y equals negative 3x plus 1, right where it crosses the y-axis. Okay, it is at plus 1. Well, and now the most beautiful exercise from this list, it is this. What is that? Well, we're going to specify what those letters need to be so we can have ourselves. Let's analyze everything, okay? Well, first, I'm going to build like this. To be, first, to be an arithmetic progression, C must be equals 1. Okay, this is the first point. but it could also be 0. Okay, it cannot be greater than 1. So let's put it like this. It must be 1 or 0. Okay, because if it's 1, and let's make it something different here. If it's 1 and k it is greater than 0, so we are going to have an increasing arithmetic progression. If c equals 1 but k it is less than 0, then we are going to have a decreasing arithmetic progression. Okay, and the second, what happens if c equals 0? Well, in this case this is going to be just 1. Okay, and we're going to have a constant. Whatever is k and b, both are going to be a constant. Then we're going to have a constant arithmetic progression. And what happens if c it is different than 1 and c it is different than 0? Then this is not an arithmetic progression. Okay, I didn't make the chart in here, but just in case c equals 0, we're going to have, I'm going to try to draw in here, in this color in here maybe. In the end it's very difficult to put everything together, there's too much information, but we can handle. Well, if c equals 0, we are going to have something like this. It's going to be a horizontal. Might be a plus or minus horizontal, it's not the case in here, right? But it's going to be a constant. Okay, it's going to be like y is going to be any number. Y is going to be, for instance, k. Okay, and that's it. Okay, I believe that the most important thing is here, when you have your sequence, just think about the common difference, the d. Once you got the d, you know what to do. And if you don't have your sequence but you have the general term of this sequence, well, if it is first order, it is c equals 1. I mean, yeah, this one, right? It is a first order degree in here, the power, okay, it is just 1. Then we know that it is going to be arithmetic progression. If this is positive, it is going to be an increasing arithmetic progression. If it's negative, it is going to be a decreasing arithmetic progression. And if this is 0, n to the power 0, in this case, okay, this is going to be just 1. This term in here is going to be 1. And an is going to be a constant. Meaning, an is always going to be the same number, just like this. And we are going to have a constant, and therefore it's going to be a constant arithmetic progression. Okay, that's it for those exercises.